Okay, so this is our short, less than 15 minutes, introduction to basic atomic chemistry. So we started this a little bit in class, and here's more. So chemistry was one of the earlier sciences. Read the joke, laugh heartily. Okay. And it came out of sort of the study of the elements, trying to balance them, and eventually to try to make them into gold. Alchemy was the real precursor to modern chemistry. So, basic chemistry really starts out with atoms. So, atoms are the smallest unit of matter in the universe. The word atom itself actually means indivisible. We know now that, of course, it's not totally indivisible because atoms themselves are made up of smaller particles, neutrons, protons, and electrons. But that's okay. Elements are specific kinds of an atom. So every atom with 6 protons, for instance, is always carbon. That's a particular element. And every atom with 26 protons is always iron. Doesn't matter where you are in the universe, there's 26 protons, it's iron. So we call those elements. Atoms we know now are mostly empty space. They have a nucleus at their core. You can see it there. And then the electrons are in energy levels around the outside of the nucleus in what we call the electron cloud. We'll do a lab about that later. So here you can see the electron cloud. Electrons are very, very small, negatively charged, and they're so small that they basically have no mass. It's negligible compared to the rest of the atom, so we just consider it to be 0. And they move, as I said, in orbitals at different energy levels. So the farther away from the nucleus, the higher the energy level. To sort of simplify this, sometimes we will use rings to indicate the electron energy levels, even though that's not really showing what they look like. So in the nucleus, again, we have protons and neutrons. Protons are positively charged, positive, and their mass is 1. Neutrons have no charge, so we call that neutral. So neutral, neutron, and their mass is also about 1. So most of the mass of the atom, all of it essentially, comes from the nucleus, from the protons and the neutrons. Here's a little summary, and this will be on Schoology as well, but mass of electron, 0, charge of -1. Proton, mass is 1, charge is +1. Neutron, mass is 1, but it has no charge. It is important when atoms undergo radioactive decay. So sometimes those will come into effect, but not very often. You may have seen before, you've definitely seen a periodic table before. But elements are shown on the periodic table using some variation of this format. You always have the symbol, so in this case it's carbon, usually an abbreviation of the element name. There are some symbols that get their names from Latin. And the atomic number, which is the number of protons, usually goes here. Sometimes on our periodic table in the classroom, it's actually up in the top corner. So you would have carbon, 6, and then the mass. So mass on the periodic table is an average, so it would look more like this with 12.01 instead. Either way, you always have the smaller number is the atomic number, the number of protons, and then the other number is the mass, either the mass number or the average atomic mass. The atomic number, which is the number of protons, determines the identity of the element. So, as I said at the beginning, anything in the universe with 6 protons is carbon. Anything with 1 proton is hydrogen, and so on. So it's a universal truth. This is an example of a simplified electronic model. So you can see here's the nucleus, and then we have outside it energy levels. So rather than showing them as a cloud, they're just rings. And the first energy level can only hold 2 electrons. You'll talk more about that if you take chemistry in the future. And then after that, the energy levels can have 8 electrons. So you can see here we have the first ring with just 2, and then it's full. And then we have 8 electrons, and it's full. And then 8 electrons, and it's full. We keep adding ring after ring. Atoms can come in what we consider like different forms. There are only a little over 100 elements on the periodic table, but they can vary in some differing ways that give us about 2,000 different atoms. So the first sort of way atoms can be different is if they become ions. So that's when electrons, which are the outermost part of the atom, are either gained or lost. Neutral atoms, and those are what we've been talking about so far. They have equal protons and electrons, so their charge overall is 0. If electrons are lost, then you get a positive charge, a positive ion, because you're losing negative charges. Conversely, if you gain electrons, then there will be a negative charge, because you have more negatives than positives. So that happens sometimes when atoms react with one another. There are also what we call isotopes. So isotopes are the same atom, same atomic number, same protons, but they have different number of neutrons. So you can see here, this is hydrogen, sort of regular hydrogen, with 1 proton right there in the middle and 1 electron. Since there's only 1 proton, the mass is 1. here we have what's called deuterium. So it's again hydrogen because there's just one proton, but now there's also a neutron. So we have a total mass of 2. Here, still hydrogen, still one proton, but 2 neutrons for a total mass of 3. And these isotopes are things that just happen naturally. And the way the mass is written on the periodic table, the decimal number takes into account these different types of isotopes. That's why it's different than this just single-digit mass number. So when you're looking at this sort of notation rather than the periodic table, you're getting the mass number rather than the average. So it's the number of protons plus the number of neutrons. And we'll talk about how they calculate it on the periodic table a little bit later on. That is all.